Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk to Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All About Electricity, Part 12. Lithium Iron Phosphate Batteries, Part 6. We will continue discussing the use of single 3.2-volt lithium iron phosphate cells for your battery bank, and we'll cover the Battery Management System, or BMS for LFP batteries. If you build your own battery system from LFP single cells, a BMS is the best money you can spend to protect your battery. If you purchase a pre-built LFP battery, make sure it includes a good BMS. I will put links to a few of the best BMSs in the video description. A battery management system does many things, including the ability to see the total battery voltage and the voltages of the individual cells, plus how much current is being put into the battery during charging, and how much is being drawn from the battery as you run electric equipment. It can display other health information about your battery, such as session values and event counts. Capacity, balancer, and protection configurations are usually available with a good BMS. There are other protection features you should have on your battery system, but a BMS will protect your battery. Now to some specifics. You will need to use your phone or tablet to remotely connect to the BMS on each of your batteries. This is done via Bluetooth or Wi-Fi, so an internet connection is not necessary. If you have more than one battery, you will need to select the battery you want to monitor or configure. You can only monitor one battery at a time with a BMS. My BMS shows the total voltage of the battery and the individual voltages of each cell in that battery. The difference between your highest cell and lowest cell is also displayed. This will show you if that battery is balanced or not. Remember that most times the difference between the lowest and highest cells will be higher the nearer you get to full charge or full discharge. This is normal and doesn't mean your battery is out of balance. What you want to see is the battery imbalance when the cells are 3.1 to 3.2 volts. The BMS should also show you how much current is being put into the battery via charging, or how much is being drawn from the battery. Other health information about your battery that might be shown could be the maximum and minimum total voltage of the battery, the maximum charge and discharge current in amps that the battery has reached, and may show the maximum charge and discharge power in watts. This BMS will allow you to reset these fields. There may be an event count section. This is a quick way to see if any of the protections have activated and how many times since the last reset. This will help you identify if you are starting to have any battery problems or if you need to make changes to your charging or discharging of your battery. Before purchasing a BMS for your DIY-built batteries, be sure it allows you to customize its settings. We will cover my settings in another net. My BMS has a capacity configuration section. You will be able to enter the capacity of your battery in amp hours, so the BMS knows about your battery. This BMS requires you to enter amp hours as milliamp hours, so a 280 amp hour capacity battery would be entered as 280,000 milliamp hours. You may be able to enter how many amp hours determine a full charge-discharge cycle. You can configure at what voltage a fully charged cell and full discharged cell will be. This must be entered in millivolts, but a different BMS may not require this. With this BMS, you are able to configure the balancer configuration. You can turn balancing on or off, and whether to balance when charging only. You can set the voltage of the cell, which will turn on balancing if any of the cells reach that voltage. And if the difference between the lowest and highest cells is more than the amount you enter in the delta to balance field. A good BMS will allow you to set when your protections are activated. Some of the biggest protections a BMS can provide will either turn off the charging of the battery or stop the discharging of the battery. If any cell in your battery reaches your maximum set voltage, or if the total voltage of the battery reaches your maximum set voltage, the BMS will stop charging the battery. This is also true for a low cell voltage or low total battery voltage, which will not allow any current from the battery to be used. These protect your battery from overcharging and over-discharging. Remember to watch the expanded presentation on our YouTube channel, which will have visuals for better understanding. For those who want more details about LFP batteries, I have provided links in the video description to a few of the most reliable people on YouTube who can give you more information than I can here. Next week, we'll continue our All About Electricity series and discuss how do I have my BMSs set up and why. We will start discussing solar panels and charge controllers after that. If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.